We're solving problem 14 from the 2020 AMC 12B. Bella and Jen play the following game on closed interval 0 to n of the real number line, where n is a fixed integer greater than 4. They take turns playing, with Bella going first. At his first turn, Bella chooses any real number in the interval 0 to n. Thereafter, the player whose turn it is chooses a real number that is more than 1 unit away from all numbers previously chosen by either player. A player unable to choose such a number loses. Using optimal strategy, who will win the game? So it says n is greater than 4, and that's basically our only constraint on being a number line of 0 to n. To best replicate what this means, we want to first play the game. So, for example, we can just test out a number line from 0 to 9. 1, 2, 3, 4, 5, 6, 7, 8. So each of these tick marks represent one whole integer step from each other. And for simplicity, let's assume that when Bella and Jen play this number line, they only select the integers to make things easier. Well, if Bella goes first, he can go, say, here. Jen can respond going, say, here. And then up on this point, since they're playing the best they can play, Bella goes here and wins the game. Now, this probably was not optimal strategy for Jen, because she probably could have gone to a better move. But you don't know that. So you can keep on trying all different configurations. Basically what you do is, well, since you see this number line, you can go anywhere at first, right? And there's obviously a middle point. So between that middle point, if we have a middle point and two other segments of integers, right? Well, there's essentially two sets of the same amount of numbers if you pick that middle point. So basically all of this can be split into two, I guess. So once you try the game enough and see all the optimal strategies, in this 0 to 9 case, we will find that Bella always wins when playing an optimal strategy. So this immediately rules out answer choices B, because Jen does not always win. E, because 9 is greater than 8. And, and D, because 9 is odd. And it says Jen wins only if n is odd. Then it goes to these two winning scenarios. We don't know which one is true for now, but we can test another value where n is equal to 10, because 10 is even. So we can form the number line 0 to 10 with 9 ticks in between. 1, 2, 3, 4, 5, 6, 7, 8, 9. Assume they only play the integers again. So in this case, we have a middle point, which is 5. So what we want to do in this case is, well, if Bella, say she picks on her first move any number that's not the 5, it'll result in a smaller range in one side, but a much larger range in the other. So, but if she picks the midpoint, well, then the whole point of the game is to basically close the gap between the ranges. Jen, or let's say, optimizes this one 8 or something like that, because you want to pick a point such that it's not next to 2 or quote unquote more than 1 unit away from all numbers previously chosen. Her reasoning is that you cannot pick any number more than 1 unit away from this plan of 8 because it's a B and then the other is just the end of the line. Bella can counter this by playing right here, number 2, and effectively wins the game like this. Now, we find that her best bet is to always play the middle point to get more control, but we have proven that you can test this, but if Bella keeps on playing with different strategies, we find that she can win with an optimal strategy in an even, where n is even. So therefore, A is Bella always wins. That's our answer.